Here is a piecewise defined function that we want to graph, and it's a little bit more complicated than just an easy sort of example. We've got three different things we're trying to graph, and so our first graph right here, when x is less than or equal to -1, our graph is 3. So our y values are 3 until we get to -1, and it's equal to at -1. And so it's just a horizontal line at 3 that keeps going to the left as far as it can go. But it's a filled in dot at -1 because it is x is less than or equal to -1. This second equation is going to be probably a little tougher for us to graph because it's a parabola, and so what we can do is you can plug this into your calculator if you want to, or you can plug in and use a table of values. And if you put it in your calculator, that's what I would recommend you do, is you actually just go and look at the table instead of focusing on the graph itself. So on your table of values you have -1, 3. Well, that is this point that we've already got drawn. Now it's not equal to at that point, but what's going to happen is because those two equations meet, we're actually going to end up with a continuous curve that doesn't jump. At 0, it's at 5. At 1, it's at 3. And at 2, which we're equal to, it's at -3. And this is a parabola, so we got to do our best to make this look like a parabola. There we go. And then when x is greater than 2, we have this line that we're graphing. Now if I'm using slope-intercept form, this could prove kind of challenging. You could kind of make it really light so that you can erase it. We're starting at -5, and then we have a slope of 1/2, and so this right here is our first point that we're going to have, and it's going to be a filled in point. So I'll get rid of my little orange spots. So we start here, and then we're going to keep going up 1 and over 2. And then draw our line, and it keeps going to the right. So this is an interesting looking curve. You definitely couldn't get that with just one equation. If this had been at, say, -4 instead of -5, it looks like our last two graphs would have met as well, making this completely continuous, but that didn't happen. So that's our graph of that.